Hello everyone, my name is Dr. Roshan Kumar. I'm an assistant professor in SR University, Warangal. So, in previous lecture, we have completed a special type of diode. One is varactor diode, tunnel diode, LED, and photodiode, and lasers. Now, in this lecture, we have delivered pin and avalanche photodiodes. So, So I am going to explain a very important optoelectronics device known as the pin photo device. So a photodiode is a semiconductor device that convert light energy into electrical current. It operates based on the principle of photoelectric effect, where incident generated charge carrier. Among different type of photodiode, the pin photodiode is widely used due to its high speed and sensitivity. So, structure of pin diode. The term of pin stand for P region, that is positive, and I stand for I region, that is intrinsic or undoped region, and N is negative region. The key feature is the intrinsic layer placed between the N-type P region and N regions. This intrinsic layer is lightly doped or completely undoped with which increase the width of depletion region. So, working principle of pin diode: when light falls on the photodiode, photons enter the intrinsic region. They generate electron hole pair due to the built-in electric field. Electron move towards the N region and holes move towards the P region. This movement of charge carrier produce photocurrent, which is proportional to the intensity of light. So, why intrinsic layer is important in pin photodiode? The intrinsic layer provide several advantages in pin photodiode. So, wide depletion region, more photons absorption, and reduce the capacitance for faster response, and the device improve the efficiency because of the pin photodiode are much faster than PN junction diode. So, mode of operation: pin photodiode mainly operated in reverse bias conditions. Reverse bias means you have to provide the reverse bias voltage in the photodiode, pin photodiode. Using reverse bias, increasing the electric field It improves carrier separation, results in faster response time and better performance. So, a basic pin photodiode generally operated in reverse bias mode. The P region is connected to the negative terminal of the battery and the N region is connected to the positive terminal of the battery, which is clearly observed in that graph, in that structure. This created a strong electric field across the intrinsic region. So, photon absorption when light falls on the device. Photon enter the intrinsic region. If photon energy is greater than equal to band gap energy, it generates electron hole pairs. The generated electron hole pair generate because of charge carrier inside the intrinsic layer. Each absorbed photon produces one electron and one hole. This region is very important because of its wide, so more photons are absorbed. It increases the quantum efficiency. Now let us understand the carrier separation by applying electric field. Due to the applied reverse bias, the electric field quickly separate the carriers, means that electron move towards the N region. Similarly, holes move towards the P regions. This movement of hole and electron is phenomenon is called electron separation. This process is very fast due to the strong electric field. So larger deflection region in that intrinsic layer, and intrinsic layer reflected in that structure, and it is denoted for I. Next, flow of photocurrents. How to flow the photocurrent in pin photodiode? The moment of electron and hole generate a current in the external circuit is called photocurrent. It is denoted by IP. So, photocurrent is directly proportional to the intensity of incident light. So, more light, more carrier and higher current, means if light is increases, carrier also increases, and similarly current is also increases in the pin photodiode. So what is the key feature, working key feature? Faster response time due to reduced capacitance, high sensitivity, more absorption in I region, inversion region, intrinsic region, low recombination losses. Next, so in this slide we are analyzing how photon absorption occur inside the pin photodiode. Let us consider that a photon flux phi naught is incident on the P plus region of the diode. Since the P plus layer is very thin compared to the intrinsic and end region is most of the light pass through it and enter the intrinsic region where actual absorption take place. Now, an important point to understand is that photon absorption is not a uniform throughout the device. As a light travels deeper into the intrinsic layer, its intensity gradually decreases due to absorption. We can see in that picture this variation is mathematically expressed as that phi x is equal to phi naught e raised to power a into x. So here phi x represents the photon flux at distance x inside the material, and phi naught is the initial photon flux at the surface, and alpha is the absorption coefficient, which depends on the material. X is the distance measured across the intrinsic layer. So this equation shows that the photon flux decreases exponentially as it is penetrates deeper into the device. So most of the photons are absorbed near the entry region and fewer photons reach the deeper parts. This results in what we call non-uniform photon absorption. This behavior is very important because it is directly affect the generation rate and electron hole pairs. The efficiency of photodiode, pin photodiode in intrinsic layer play the crucial role by allowing current absorption of photons, which is ultimately determine the performance of pin photodiode. So next is, so this is a equation to calculate the photon current and application. Pin photodiode are widely used in modern electronics device due to their high speed and sensitivity and reliability. Let us look at some important application for optical communication system. Pin photodiode are extensively Used in fiber optic communication, they act as optical receiver, convert light signal into electrical signal used in high speed internet and data transmission. So medical instrument, they are used in device like pulse oximeters, CT scan, blood analysis equipment. So the device is really a accurate detection of light intensity. Another application in infrared application, pin photodiode are used in remote control receiver and IR sensor and detectors night vision system. So they are effectively detect the infrared radiation. And also another application, light detection and measurement. The light meter automatically light system, camera, exposure controller, they provide the precise measurement of light intensity. Industrial and safety system, smoke detector, object detector system, barcode scanner. They help the sensing the automatic process. And also use another application, high speed switching in RF application due to the capacitance and faster response used in RF switching for microwave communication system. So this is all about for pin photodiode application. Next is avalanche photodiode. So what is avalanche photodiode? A avalanche photodiode is highly sensitive semiconductor photodiode that convert light into electrical current similar to the pin photodiodes. However, the key difference is that it provides internal gain through a process is called avalanche multiplication, making it much more sensitive. So structure of avalanche photodiode, that APD typically consists of P region, intrinsic region and multiplication region and N region. It operates under the high reverse bias voltage close to the breakdown. Means the working and the APD occur in working of APD is three steps: photon absorption, incident photon generated, electron hole pair in the intrinsic region, acceleration of carrier due to the strong electric field, carrier acceleration towards the respective terminal, and avalanche multiplication, a, a high energy electron collide with atom generated additional electron hole pair. This lead to the chain reaction is called impact ionization. As a result, one photon can generated multiple charge carrier and increasing the current. So key concept of internal gain, the multiplication factor is called gain. Typically value of gain is 10 to 100 and output current is equal to M into primary photon current. This make APD is more sensitive than PIN photodiode. So advantage is very high sensitivity, suitable for low light detection, faster response, internal uh, amplification, no external amplifier needed. So construction of avalanches photodiode. So it has four region, that is N plus region, P region and intrinsic layer and P plus region. The N plus and P plus region are heavily doped and intrinsic layer region is lightly doped. So avalanche's photodiode is especially designed to achieve internal amplification of photon current. Its construction is more advanced than a simple PN or PIN photodiode. So basic layer of a structure of APD is typically consists of the flowing layer. P region, that is P plus region, is heavily doped. Intrinsic or absorption region, that is denoted by I layers, and multiplication region, sorry, N plus region is heavily doped. These layers are arranged to create a high electric field region necessary for avalanche action. Absorption region, this is usually a lightly doped intrinsic layer. So incoming photons are absorbed here and generate the number of electron hole pair. So purpose efficient light absorption. So multiplication region located near the P region, designed to have a very high electric field. Purpose accelerate the charge carrier causing the impact ionization, produce avalanche multiplication. So electric field distribution, the electric field is non-uniform, low field in absorption region, avoid uh, premature multiplication. So high field in a multiplication region enable avalanche effect. So type of APD structure. A reach through APD depletion region extend through absorption layer, simple design, moderate performance, and separate absorption and multiplication APD, separate region for absorption and multiplication. So better performance and low noise widely used in optical communication. In reverse bias APD operate under the high reverse bias voltage. The voltage is close to the breakdown region, essential to create a strong electric field. The key design goals, the construction aim to achieve high gain, multiplication factor, low noise, faster response time, efficient photon absorptions. So the avalanche photodiode work on the principle of photovoltaic effects combined with avalanche magnifier. The reverse bias operation APD operate under high reverse bias voltage close to the breakdown to create very strong electric field. This strong electric field is a key avalanche action. So photon absorption, when light enter to the device, photons are absorbed in the absorption intrinsic region that generated due to this absorption of light. The device generates electron hole pair. When light intensity is low, the device hole pair generation is less. Due to the less hole pair generations, efficiency of device is very low. Due to uh, high moment of charge carrier, the electric field is very strong. For N region, hole moves to the P region. This carrier gains the high kinetic energy. Avalanche multiplication या impact ionization, high energy electron collide with the lattice atom. This collision creates an additional electron hole pair. This process is called impact ionization. So newly generated carrier again accelerate and collide. A chain reaction occurs. This, this is called avalanche effect. So multiplication gain is a total current upon primary current, that is a multiplication factor. Typically the value is 10 to hundreds. So how to generate output currents is a avalanche photodiode. It is produce the larger output currents. This make a APD highly suitable for low light detection. So important, very high sensitivity, faster response time, internal amplification. So avalanches slow down. The period of modulation signal would be 2 tau t, so that the frequency would be 1 upon 2 tau, that is 5 Hz. The avalanche photodiode current gain is 20. The gain bandwidth product is 100 GHz. So what is the difference between pin photodiode and avalanche photodiode? So pin photodiode response time is very low, but avalanche photodiode response time is very high. Pin photodiodes work in reverse bias. Voltage is very low, but avalanche photodiode reverse bias voltage is very high. So low temperature, stability, but avalanche photodiode is high temperature stability. The multiplication of carrier current can cause the amplifier current value, and the output current is low compared to the pin photodiodes. So this is all about pin photodiode and avalanche photodiode. Both diode work under reverse bias, but pin photodiode require very low reverse bias voltage and avalanche photodiode require very high reverse bias voltage. So thank you for watching my video.